Hello, so here we see another BJT circuit where the NPN transistor is shown. This is an NPN transistor as the direction of the conventional current is shown coming out of the emitter right here. When you see such arrow, it is an NPN transistor and you can say that the current is flowing from collector to the emitter. From collector to the emitter. Now let us have a understanding of this circuit and how it works. So you have a base pin, collector pin and emitter pin, the three pins of the transistors. This is your N region, this is your P region and this is your N region again. That makes your transistor NPN. Now the input signal is applied to the base terminal and the output is taken from the emitter right here. So again the input is applied to the base and output is taken from the emitter. So we can say that the collector is tied to the supply voltage, positive supply voltage. So such configuration is called as common collector configuration, that is CC. Now what's the use of this common collector configuration? So we assume that the transistor is biased with the DC operating point, that the supply voltage is here, and we use some external resistors not shown over here so that we make this input junction, which is base to emitter junction, forward bias, and the base to collector junction reverse bias. Okay, so here the drop that will come is VBE across the forward bias junction, and here the drop would be VCB, that is the reverse bias junction. So when you have such biasing conditions so that the base emitter junction becomes forward bias and base collector junction becomes reverse bias, you say that the transistor is biased in an active mode or active region. With that said, when you apply an external input signal, let's say you have a AC signal that comes applied at the base of the terminal, so we can say that the base current flows inside the base terminal, emitter current is shown right here, and the collector current direction is also like here. So neglecting the base current contribution, we say that IE, that is your IE, would be equal to IC, that is your emitter current will be equal to the collector current. Now you can say that here is that voltage drop which is VBE, so you can apply the KVL, Kirchhoff voltage law, into this loop. So you can say that V in minus VBE minus IE times RE is equal to 0. So you again can see that the loop right here shows that V in minus, this is the drop VBE, okay, minus the drop across this resistor, because the current that is flowing here is IE and we know that it is equal to IC, neglecting the base current contribution. So with this we know that IERE, which is the drop across this resistor RE, is nothing but your V out. So put the value of V out right here in this equation, and with that we can write V out is equal to V in minus VBE. V in minus VBE. So you can say that The output voltage in such circuit will always be equal to the input voltage minus this base emitter junction voltage drop, which is usually 0.6 or 0.7. So such circuit is called as voltage follower circuit, which is a typical application of BJT biased in common collector mode. It is also called as emitter follower because the voltage at the emitter follows the voltage at the base. So that was all about your common collector transistor configuration. So if you like this video, share it with others.